Electromagnetic Induction, Revision of Basics. North pole implies current flowing in the anti-clockwise direction. South pole implies current flowing in the clockwise direction. When the north pole end of a bar magnet is moved towards a solenoid by Lenz's law, a north pole is induced and current flows in the coil in the anti-clockwise direction. In diagram 1, the north pole end of a bar magnet is brought near a solenoid. By Lenz's law, a north pole is induced and current flows in the anti-clockwise direction. In diagram 2, the north pole end of a bar magnet is brought near a solenoid. By Lenz's law, the nearer end is induced north pole and the further end south pole. In the nearer end where north pole is induced, current flows in the anti-clockwise direction. Diagram 3. North pole end of a bar magnet brought near a solenoid. North pole is induced by Lenz's law and current flows in the anti-clockwise direction. Diagram 4. North pole end of a bar magnet is brought near a solenoid. By Lenz's law, the nearer end induced north pole, the further end induced south pole. The nearer end where north pole is induced, current flows in the anti-clockwise direction. In diagram 5, when the north pole end of a bar magnet is moved away from a solenoid, by Lenz's law, the nearer end is induced south pole and the further end north pole. The nearer end, which is south pole, has current flowing in the clockwise direction. Diagram 6. When the south pole end of a bar magnet is plunged into a solenoid, by Lenz's law, the nearer end of the coil will become a south pole and current will flow in the clockwise direction. Diagram 7. When the south pole end of a bar magnet is moved away from the solenoid, by Lenz's law, the nearer end of the coil will develop north pole and current will flow in the anti-clockwise direction. Now we come to ICSE 2024 Specimen Physics question number 9, part 3. Part 3A. Answer: north pole. See the diagram on the left side. When the north pole end of the magnet is leaving the coil, by Lenz's law, the bottom end of the coil will develop south pole and hence the top end develops north pole. This is shown again in diagram 8. When the north pole end of the bar magnet is moving away from the solenoid, the nearer end by Lenz's law becomes south pole and the further end becomes north pole. In the next diagram, when the south pole end of the magnet enters the coil, by Lenz's law, the top end of the coil will develop south pole. Direction of current at the top end will be clockwise, that is B to A, not A to B as given in the question paper. This is explained again in diagram 9. When the south pole end of the bar magnet comes near the solenoid, by Lenz's law, the nearer end becomes south pole and the further end becomes north pole. The nearer end, which is a south pole, has current flowing in the clockwise direction, that is B to A. Part B. Answer. The direction will be from A to B. See the two diagrams given on the top. When the north pole end of the magnet leaves the coil by Lenz's law, the bottom end will become south pole and the top end will become north pole. Current will flow at the top end in the anti-clockwise direction, that is A to B. See diagram number 10. When the north pole end of the bar magnet is moving away from the solenoid by Lenz's law, the nearer end will become south pole and the further end will become north pole. The further end in this case is the top part of the solenoid, as in the previous diagram. Since it is a north pole there, current will flow in the anti-clockwise direction, that is A to B. C. Answer. Lenz's law. D. Answer. Increasing the number of turns in the coil, or using a stronger magnet, or magnet moved more rapidly.